So question 5 asks us to comment on the roots of the following quadratic equations. That should be a red flag for us, or alarm bells, that we're going to have to use that discriminant. And we have to remember those rules that went with the discriminant, so what it meant for it to be greater than 0, equal to 0, less than 0, and so on and so forth. So for the first one, we're using the same rule, b squared minus 4ac, remembering as well that that is actually part of our quadratic formula. So we have to label the letters in the same way, b being the one in front of the x, a the one in front of the x squared, and c being the last constant number on its own. So 36 minus 20, which works out to be 16. 16 is greater than 0, so therefore the roots are real. We have real. And we have two distinct real roots. So two different real roots. For the second one, we will have 2 squared minus 4 by 5 by minus 10. So 4, and we will have 4 by 10 by 5, which will give us 200. So that's 204, which is greater than 0. So therefore, once again, two distinct real roots. Next part, we do the same again, and this time we're going to include that a. 2a squared minus 4 by 1 by a squared, and we will get 4a squared minus 4a squared, which is 0, and that means for us two equal real roots. And for the last part, this question has been presented to us in our completed square format, and we can actually use this format to comment on the roots, as we talked about in class. So first of all, we can bring over that 1 to the other side and get 11. We can divide by that 3. We will get 11 over 3. And we will then get 4x minus 2. We can take the square root of both sides. So our answer is plus or minus the square root of 11 over 3. And again then, so really we would have 2 plus or minus the square root of 11 over 3. And if we just finish that out, just for the sake of clarity, divided by 4. Okay, and we can see here that we haven't had the square root of a minus number or anything like that. So really what this says for us is we have two distinct real roots. And if we wanted to go a step further, we could say that they're non-rational. They're not rational. Okay, so we're going to have a decimal. If we used our quadratic formula, we would actually find that we have the same answer there.